Hi students, let us talk a little bit about solution of quadratic equations. Uh, we're going to see in this video how to solve quadratic equations. And the first should be to define what a quadratic equation is. So when we have an equation of the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers, and a is not equal to 0, we have a quadratic equation in standard quadratic form. Now, if we want to solve this quadratic equation, we're going to have different methods that they are going to let me solve the equation. It could be by factoring, by taking a square root, by completing the square, and by using the quadratic formula. I will give you some examples, of each of these methods of solution of quadratic equations. So let us start with the solution of quadratic equations by factoring. So to solve quadratic equation by factoring, we're going to be using the zero product property. And in this zero product property, we have that if a times b is equal to 0, so if the product of two factors is equal to 0, then a is equal to 0 or b is equal to 0. So if we have a product of two or more factors and that product is equal to 0, it's because at least one of the factors, must be equal to 0. This zero product property is the foundation of the solution of quadratic equation by factoring. So let us solve some equations by factoring. Let us start with a very easy case, right? Suppose that I have x squared equals 2x, and I will solve this by factoring. So to solve by factoring, the first I have to do is to group all the terms to the same side or on the same side in order to have my equation in standard quadratic form. So one of the side of the equation must be 0, while in the other one we have all the terms, so we have a quadratic expression. So subtracting 2x from both sides, we get that x squared minus 2x equals 0 here. Now you have to ask yourself, what is the easier way to factor this polynomial? X squared minus 2x, or basically what is the only way that in this case we have to factor this polynomial x squared minus 2x. And in this case, this will be by factoring out the greatest common factor. Remember that when we studied the factorization of polynomials, we defined that we had different strategies, right? Okay, or we have a strategy with different steps, right? And the first step always when factoring polynomials is to look for a greatest common factor. And if there is a common factor, you will factor that common factor out. When I analyze x squared minus 2x, I have a common factor x. So I will be factoring the x out. And and then I get in parentheses x minus 2. As you see now, this x is my first factor, this x minus 2 is my second factor. So this is like a times b equals 0. You know, so my factor x is like the factor a in my zero product property. My factor x minus 2 is like the factor b, right, in my zero product property. So what I have to do is to make x equals 0. And I don't solve that anymore because it's already a solution. And then I have x minus 2 equals 0. So solving for x equals 2. You know what it means? It means that now, in this case, we have two solutions. And when we are solving quadratic equations, we are expecting to have two solutions always, right? So one of the solutions will be 0, and the other solution is 2. So I have 0 and 2 as solution of my equation. Let us see a second case here. Let's say 4y squared minus 49 equals 0. So in this case, my quadratic equation is in a standard quadratic form because the right side is 0. I mean, one of the sides of the equation is 0. All my terms are together in one side. So again, I analyze the quadratic expression that I have over here. I say it's a binomial. So I have to factor this binomial. But when I look at the binomial carefully, I recognize, that this binomial is a difference of squares. So I will work on this binomial, using what I know about difference of a square, about the factorization of difference of squares. So remember that if you have a squared minus b squared, so when you have a difference of squares, the factorization in that case will be a plus b times a minus b. So a difference of squares is a two terms polynomial where the sign here in between the terms is negative and where both terms are perfect squares. 4 is perfect square because it's coming from the product of 2 times 2, while square is perfect square because whenever the exponent is even, the variable expression is perfect square, and 49 is perfect square because, of course, it's coming from the product of 7 times 7. So if I then apply the rule of a difference of a square, I know that the factorization of 4y squared minus 49 is factors of 4, 2 times 2, factors of y squared, y and y, Then always in the difference of a square, we have one sign here positive and the other one negative. So it's a plus and minus in this other side. And factors of 49, 7 and 7. So I have 2y plus 7 times 2y minus 7. I will make the factors equal 0, so 2y plus 7 equals 0. So 2y equals negative 7, y equals negative 7 over 2. And then we have 2y minus 7 equals 0. So 2y equals positive 7, y equals 7 over 2. So my solutions in this case are negative 7 over 2 and positive 7 over 2. So we have solved this equation by factoring also. But then now let us solve an equation, that involves a trinomial instead of a binomial. So suppose that my next equation is this one that says, x squared, let's see, minus 7x plus 10 equals 0. So in this case, the quadratic expression is a trinomial. So since this quadratic expression is a trinomial, now I have to recall, how we factor trinomials. So in this case, I will be looking for the factors of 10. We look for factors of 10 such that the total of those factors is minus 7. So y10, we're looking for the factors of this number, for the factors of the constant c, such that the total, of these two factors, when we add those factors, we get minus 7, we get b. Remember, this is ax squared plus bx plus c equals 0. This is, the form of a quadratic equation, standard quadratic form. So which are those numbers that you multiply and you get 10, and then adding the numbers you get minus 7? Of course, are negative 2 times negative 5, because when you multiply negative 2 times negative 5, you will get negative and negative positive, and 2 times 5 is 10. And when you combine, negative 2 plus negative 5, right? That means adding those factors, we're going to get, in this case, what? Minus 7. So the numbers I'm looking for are negative 2 and negative 5. So I can say that the factorization here is x minus 5, x minus 2 equals 0. If you want to double check, you multiply. So you say x times x is the x squared I have over here. X times negative 2x, and negative 5 times x is negative 5x. Negative 2x minus 5x is minus 7x. And negative 5 times negative 2 is positive 10. So now we make the factors equal 0. So x minus 5 equals 0. So x equals 5. X minus 2 equals 0. So x equals positive 2. And I found the solutions that are 2 and 5 in this case. So this is how you solve by factoring, the quadratic equations. We can have a great diversity of examples, right? I just explained a few of them. Let us then analyze how we solve by taking the square root. So how we solve an equation by taking the square root. So by taking the square root, we're going to use, or we're going to base this method in the taking the square root of both sides of the equation property. That means we say that if the square of a variable is equal to a number a, then the variable will be plus minus the square root of that number a, where a is, in this case, how we're working with equations, in the set of real numbers, so a is a real number. We're going to later study the complex numbers, and we're going to see that a can be also a complex number. But as we're working now in the set of real numbers, let us say that a is a real number. So what it means, if I have x squared equals 50, I will be able to solve this equation by taking the square root. So the idea is always to rewrite this as x squared equal a number. So I can say that x is equals plus minus the square root of 50. I know that 50 is not a perfect square number, but I know that 50 contains a perfect square factor 25. So I'm going to say that x is equal plus minus the square root of 25 times 2. So using the product property of radicals, I can say that x is equal plus minus the square root of 25 times the square root of 2. So x equals plus or minus 5 square root of 2, because the square root of 25 is 5. So which are my solutions in this case? In this case, I have two solutions that are negative 5 square root of 2, and positive, sorry, let me erase here, just to, and positive 5 square root of 2. So those are the solutions of my equation, in this case. But this is a very simple equation. We can complicate this a little bit more. So I can give an equation that just looks like this one, for example. I can say, for example, 3x squared, you know, uh, minus 81 equals 0. And if I have 3x squared minus 81 equals 0, you know, the easier way to solve this would be by, of course, taking the square root. So I will solve for x squared. I will isolate the x squared. So first I will be adding 81 to both sides. So I get 3x squared equals 81. I'm going to divide both sides by 3. So I get x squared equals 81 divided by 3. So x squared equals 81 divided by 3 will be 27. And then I got already, x squared equal a number. So I say that x is equals plus or minus the square root of 27. Again, 27 is not a perfect square number, but contains a perfect square factor 9. So x equals plus or minus the square root of 9 times 3. So x equals plus or minus the square root of 9 times the square root of 3. So x equals plus or minus 3 square root of 3. So I have two solutions in this case that are negative 3 square root of 3 and positive 3 square root of 3. So those are the solutions of this equation, this quadratic equation in this case. Now, I explained this taking the square root property, using the square of a variable here equal a number, but if I have instead of that the square of a binomial equal a number, that is going to work in exactly the same way, So what it means now, suppose that I have an exercise like this one. I have an exercise that is x minus 5 squared minus 2 equals 7. Suppose we have this exercise. So this is a quadratic equation because if you expand this binomial, so you expand x minus 5 squared, that would be x squared minus 10x plus 25, okay? Then minus 2, and then you bring the 7 subtracting 0. At the end, if you do it, you will get a quadratic equation in standard quadratic form. But I don't have to do that. There is an easier way to solve it. I would be basically using the same tools that I used when I was taking the square root for the square of a variable equal a number. So I will isolate the square of the binomial. So in this case, I will be adding 2 to both sides. I'm going to say x minus 5 squared equals 7 plus 2. So x minus 5 squared equals 9. And I already got here the square of a binomial, the binomial x minus 5, two terms, so it's a binomial. The binomial x minus 5 squared equal a number. So I am ready to apply the square root. So I say x minus 5 equals plus or minus the square root of 9. Of course, 9 is perfect square, so it will be x minus 5 equals plus or minus 3. So what are you doing now? You need to solve for x. So you will be adding 5 here, and you will be adding 5 here. You usually, is kind of convention. You will put the number that you are moving from left side to right side in this step in between the equal sign and the plus and minus symbols, right? So you know that this here cancel out, so we get x by itself here. So we have x equals 5 plus minus 3. And 5 plus minus 3, implies we have two solutions. One solution is x equals 5 plus 3, what is 8. Another solution, there is x equals 5 minus 3, what is 2. So in this case, my equation has two solutions that are 2 and 8. 2 and 8. Okay? So it was pretty easy, to solve the equation by taking a square root. I can give you one more example of doing this by taking a square root. So suppose that I have 2x plus 7 squared minus, let me say plus here, 1 equals 8, equals 8. So let us think, in this equation. So what are you doing in this case? You have to isolate the square of the binomial. So you're going to start by subtracting 1 from both sides. So you get 2 times x plus 7 squared equals 8 minus 1. So 2 times x plus 7 squared equals 7. Of course, now to isolate the binomial, we have to divide both sides by 2. So we say x plus 7 squared equals 7 over 2. And we finally got here, the square of a binomial equal a number. We apply a square root here. So we can say that x plus 7 is equal plus or minus the square root of 7 over 2. In this case, I'm going to rationalize this expression. So remember that when you rationalize the square root of 7 over 2, when there is a fraction under the radical, that expression is not in lowest terms. So using the quotient rule of radicals, or the quotient property of radicals, I will split this into radical expressions like this. F square root of 7 over 2 is the square root of 7 over the square root of 2. But when we have a square root, or when we have a radical in the denominator of a fraction, that expression is not in lowest terms. So I will rationalize by multiplying the numerator and the denominator by that radical that is in the denominator. So I multiply by square root of 2 over the square root of 2, and this becomes now here a square root of 7 times 2, so this is a square root of 14 over a square root of 2 times the square root of 2 is a square root of 4, what is 2. So I will be able to rewrite this square root of 7 over 2 as a square root of 14 over 2. So I'm going to say that x plus 7 is equals plus and minus the square root of 14 over 2. And then I will bring the 7 to the right by subtracting 7 from both sides. So I get x equals negative 7 plus minus the square root of 14 over 2. And that would be the solution of my equation. So my equation has solution negative 7 minus the square root of 14 over 2, comma, negative 7 plus the square root of 14 over 2. So those are the solutions of my equation for this example. So I gave you several examples of solving quadratic equations by factoring, by taking the square root now. So let us explain then some examples where we solve the quadratic equations by completing the square. So solving by completing the square, let us understand first what to complete the square is. When I have a binomial x squared plus bx, this is a binomial, I will be able to find the constant c that convert that binomial into a perfect square trinomial by adding that constant c to the binomial, to the given binomial. Perfect square trinomial. A perfect square trinomial is a trinomial where both linear factors are equal. Now, what is this number c that complete a square? So what is this constant, what is this real number c that is going to complete a square, that is going to convert whatever binomial in the form x squared plus bx we have into a perfect square trinomial x squared plus bx plus c? Well, c would be b over 2 squared. That would be the expression, to find c. So this is what to complete the square is. So let us solve by completing the square a pair of examples. So I will give an equation here. There is x squared plus 10x minus 1 equals 0. If you try to solve this equation by factoring, you cannot do it because there are no factors of -1, so that the difference between those factors be 10, right? So there is no solution for this equation by factoring. So what do you have to do to solve by completing the square? The first we're going to do will be to isolate the binomial x squared plus bx. That means I will isolate this binomial over here. So I say x squared plus 10x adding 1 to both sides equals 1. Okay, so I'm leaving by itself the binomial x squared plus bx in one side of my equation. What is my second step? I will find c, the constant that completes the square. So we know that in this expression over here, b is 10. So this is b. So I know that c is b over 2 squared. So if b is 10, then c will be 10 over 2 squared. So it's going to be 5 squared. So it's going to be 25. Okay, so it's going to be 25. Once we know the value of c, the next step, step number 3 here, would be to add c to both sides. So adding c to both sides, we get here that x squared plus 10x, what is c, 25, so plus 25 is equals 1 plus 25, because I align 25 to both sides. So then, of course, here now, x squared plus 10x plus 25 is a perfect square trinomial because we did it to get here a perfect square trinomial. So when I factor these, the factors of x squared plus 10x plus 25 are x plus 5 times x plus 5. And 1 plus 25 in the right side is 26. X plus 5 times x plus 5 is x plus 5 squared equals 26. And we got an equation here that is a quadratic equation ready to be solved by taking a square root. So the next I'm going to do is to take the square root. Exactly as we were doing in the previous examples. So by taking the square root now here, I say, okay, if x plus 5 squared is equal to 26, it's because x plus 5 is equal plus or minus the square root of 26. 26 is 2 times 13, right? The only possible factorization for 26 is 2 times 13. So we cannot factor 26. We cannot simplify the square root of 26. That means we cannot factor 26 so that we, get a perfect square factor. So it's just the product of two prime numbers, so I have no way to simplify this square root of 26. So I will just leave it like that. I never convert an irrational number, that is given in the form of a radical into decimal. So I will leave it like a radical. So now subtracting 5 from both sides, I get x equals -5 plus minus the square root of 26. I cannot combine -5 and 26, because this one involves a radical expression. This is a radical expression. This involves a radical, and this one not, right? As I cannot simplify this anymore, now I have that my solutions are -5 minus the square root of 26 and +5 minus, sorry, and -5 plus the square root of 26. So those are, in this case, the solution of my equation. Now, when we're solving equations by completing the square, we have something that we have to keep in mind. So I'm going to give you one second example here. Suppose that I have, to solve by completing the square, 2x squared, plus, let me say 18x, minus 1 equals 0. So what is going on here? This first coefficient, that we see here is called the leading coefficient. And when we are solving an equation by completing the square, we want that this leading coefficient be equal to 1. So when we have a leading coefficient that is not equal to 1, we're going to divide everywhere by that leading coefficient. So I will get here 2x squared plus 18x minus 1 equals 0. And to get the leading coefficient equal 1, I will be dividing here by 2. I will be dividing here by 2, dividing here by 2, and dividing here by 2. So I have divided by this coefficient all my terms. Of course, 2 over 2 will be 1, so this is 1x squared plus 18 over 2 will be 9x minus 1 over 2 equals 0. Now I have an equation that is ready to be solved by completing the square, So I will follow the same steps that I gave you in the other example. So I'm going to say x squared plus 9x equals 1 over 2. Just isolate the binomial x squared plus bx. Then find c, that is b over 2 squared. Since b in this case is 9, this is just 9 over 2 squared. So 9 over 2 would be 9 over 2. Well, it's a decimal number, so I'm not going to convert this into decimals, so we just square both. So 9 squared is 81 over 4. 9 squared is 81, 2 squared is 4. So 9 over 2 squared is 81 over 4. So now I will be adding 81 over 4 to both sides of the equation. So I have here x squared plus 9x plus 81 over 4 equals 1 over 2 plus 81 over 4. Of course, here I have to perform this addition. So let me show you very quick how to do the addition here. We have 1 over 2 plus 81 over 4. So I have to have the same denominator in both fractions. So we'll multiply this fraction over here by 2 over 2. Because like that, my first denominator becomes also 4. So I get 2 times 1 is 2. 2 times 2, 4, plus 81 over 4. So 81 plus 2 is 83 over 4. Right? So I got 83 over 4 here. Okay? When I add, 2 over 4 plus 81 over 4. So now I know that the right side of the equation I have over here would be 83 over 4. And in the left side, if I factor this, I will get two linear factors that are equal, that are x and x, and the factors of 81 over 4 that give you 9 when you add are 9 over 2 and 9 over 2. So it's x plus 9 over 2. So always, the number that you put over here will be basically this number that is inside the parentheses just before the square, so it's going to be b over 2. This is the number you would put over here, right? So now we have that x plus 9 over 2 times itself is x plus 9 over 2 squared equals 83 over 4. We apply square root now, taking the square root now. So we say x plus 9 over 2 equals plus or minus the square root of 83 over 4. Okay, so we can say that x plus 9 over 2 is equals plus minus the square root of 83 over 2, because we split this radical expression into the square root of 83 over the square root of 4, and then using the quotient property of radicals, and then the square root of 4 is 2, and then I bring, the 9 over 2 to the other side, so I get x equals negative 9 over 2 plus minus the square root of 83 over 2, and I have solved my equation already. So I cannot combine these because I have, this square root of 83. If you want, you can express this as a single fraction, saying negative 9 plus minus the square root of 83 all over 2, or you can just leave it like that. So your answer could be expressed either in this form, negative 9 over 2 minus the square root of 83 over 2, comma, negative 9 over 2 plus the square root of 83 over 2, or you can say negative 9 plus minus the square root of 83 all over 2. And this is another way to express, the same thing. Because if they have the same denominator, you rewrite the expression as a single fraction where you combine the you add or subtract the numerators, and you just, of course, have a common denominator too in this case. So you can express your answer in this form, or sometimes in the book they express the answer in this form. So this is how you solve by taking, by completing the square. So let us see one more example, that is how we solve equation by using the quadratic formula. And what we have to know is the quadratic formula is obtained by completing the square, the equation x squared plus bx plus equals 0. So quadratic formula is a very powerful method, exactly as by completing the squares. The quadratic formula have this expression, x is equals plus minus is negative v, sorry, let me erase this plus minus over here, is negative v plus minus the square root of b squared minus 4ac over 2a. This is what the expression of the quadratic formula is. As I said, this quadratic formula is obtained by completing the square, So basically, it's to apply a formula, right? So suppose that we have the following equation that we want to solve by by using quadratic formula. So I say solve, and I give you 3x squared, plus 5x equals, let me say, equals 1, equals 1. So I give you this equation, and I want to solve this equation by using the quadratic formula. So what we have to do in this case, if we want to use the quadratic formula, well, the first we have to have in our mind is that to solve the equation by using quadratic formula, the quadratic equation must be in the standard quadratic form. So I have to bring the 1 to the left, so I get 3x squared plus 5x minus 1 by subtracting 1 from both sides. And once you have the equation in this form, you will identify your a, b, and c values, right? So a would be 3 here, b would be 5 here, and c would be negative 1 here. Once you identify a, b, and c, you are ready to substitute those values into your formula, negative b plus minus the square root of b squared minus 4ac over 2a. So x will be equals to negative, what is b, 5, plus minus the square root of, what is b squared is 5 squared, minus 4 times, what is a, 3, what is negative 6, and that's what, sorry, what is c, negative 1, all over 2 times 3. So x equals negative 5 plus minus 5 squared is 25, minus 4 times 3, 12, minus 12 times negative 1, positive 12, so 25 plus 12, all over 2 times 3, 6, so x equals negative 5 plus minus the square root of 25 plus 12 would be 37 over 6. We cannot simplify this square root of 37 anymore, so we can leave it like that. So in this case, your solution will be negative 5. Sometimes, in the books you find that they express this together, negative 5 plus minus the square root of 37 over 6, all over 6, right? Or you can also write your solution like negative 5 minus the square root of 37 over 6, comma, negative 5 plus the square root of 37. So you separate the solutions over 6, right? So this is how you solve by using quadratic formula. The most important thing here is to make sure that your equation is in a standard quadratic form. So that was a transformation I did over here, from this step to this step over here. Okay, I just subtract 1 from both sides in order to get my equation in standard quadratic form. Once I had, my equation in standard quadratic form, I found the different values of a, b, and c, right? Of course, the values of a, b, and c, and then I substitute the values into the formula, right? So when I replace a, b, and c by the values into the formula, I was ready to do then the arithmetic, right? Just to solve the equation. I wasn't able to simplify the square root of 37, so I just did it like that. So with this video, I have been, trying to present the solution of quadratic equations in the set of the real numbers. So I hope, this will be very useful for you to study. So thank you for your attention. See you in the next video.